moving to the next part of the session that is called the Rubber Industry Tech Talk. In this session, we have Dr. Brendan Rodgers. He is the well-experienced rubber technologist. We'll be discussing about the rubber technology in next decade, what we can expect. Let me brief you about Dr. Brendan Rodgers. He has spent 42 years working in the tire and rubber industry with both the Goodyear Tire and Rubber Company and ExxonMobil. He has worked on a broad range of tire and industrial rubber products, including hydraulic hoses, conveyor belts, materials technology, and product design. He has had work assignments in the US, China, Ireland, Italy, Luxembourg, working on OEM tires, truck tires, industrial rubber products, and new tire materials technology. He is originator of a broad range of patents in tire and rubber technology and many industrial publications, including hydraulic text, rubber compounding, chemistry, and applications. And also there is a book on tire engineering, both published by CRC Press. He has a PhD in chemical engineering from the Queen's University of Belfast in North Ireland, where he studied thermodynamics. He transferred through large rubber sections and the vulcanization kinetics. I'm pleased to see you introduce these books. I think if you're interested in any of the, these are very good books published by the CRC Press, written by Dr. Brendan Rodgers, Tire Engineering and Introduction, and the second book is the Rubber Compounding, Chemistry and Applications. So please check the website of CRC Press. You may find this and how to order it. Okay? Dr. Brendan Rodgers also contributed a number of know-how webinars belong to the Technobase. One is a tire inner liner and butyl rubbers, natural rubber grades and selection, radial tire compound polymer blinds, aircraft tire materials technology, and also tire curing ladder. If you're interested in these know-how webinars, you can reach to the website know-how-webinars.com. So let's welcome Dr. Brendan Rodgers to come on board to discuss about what is the future of the rubber technology in next decade and what we can expect. Dr. Brendan, welcome to the program.
Yeah, thank you for the invitation.
So let's get started, Dr. Brendan, on various issues we'd like to talk about. So as your experience and more than 40 years experience both in the tire technology as well as the industrial rubber products, what kind of technology trend that you may foresee, in the tire and as well as industrial rubber products?
Okay, yeah. When we look at the industry, first of all, I should say that if we exclude products like the iPhone and things like that, just focus on the automotive and transportation industry, probably I would say the most complex composite product in mass production today is a tire. So when we look at that complexity of that product, and then look at the typical trends we see journalists discuss in magazines and other publications, you can basically cut those into three macroeconomic trends. First of all, I see a lot more consolidation within the tire industry, particularly in Asia. That consolidation is going to be driven by really three things. Competition. There are too many tire companies, to put it that way. The need for better quality. I can't emphasize that enough. Quality is going to be a key driver on how companies will consolidate. And then the third thing is the government guidance. Governments love the tire industry and the industrial rubber products industry for one key reason, that it's not only labor intensive, but it employs a lot of skilled labor. And in order for that industry to survive, the technology base will have to improve. And to do that is going to necessitate consolidation. So that's probably the first thing in that area. Second, materials. For example, we're seeing a lot of new technology compounds coming in, particularly in the passenger tire market. Things like these ultra high silica level tread compounds that could have potential detrimental impact on overall tire factory productivity and throughput rates. And to bring those compounds in to meet the fuel economy or the rolling resistance trends that are needed, we need to make sure there's no detrimental impact on tread wear or tire removal mileage. That's going to be a challenge. Under the materials category, I also see another area emerging in the next few years, and that is with all the new gas coming online around the world, there's an excess of methane, ethane, and propane, the C2s and 3Cs. With that low feedstock, I can see some new elastomers being developed to capture that, again, low-cost feedstock, either through dimerization of things like ethane to ethylene to and dimerizing to butadiene and so on, or polymers of that nature. The third area, again, the macroeconomic area I see is cost. This is going to be a challenge. Materials costs, Job had mentioned this in the previous discussion on natural rubber, costs are trending upwards. So we see materials going up, manufacturing conversion costs, that's from raw materials in at one end to the tire rod at the other, or conveyor belt or whatever. Those costs are going up. So when we look at the overall trend, again, at the macro level, if we go back 20 years or 25 years, the overall cost to make something like a tire was around 50% raw materials, 25% conversion costs, and 25% overhead. Today, we see that shifting more to an 80% raw materials, 10% conversion, 10% overhead. So materials are taking a bigger chunk of the overall cost to build a tire, and that's going to create challenges for the industry going forward. So in terms of the macroeconomic major trends, I see consolidation as number one, materials, and then third, costs, overall cost to manufacture. They're the three big things I see in the next 4 or 5 years.
Okay. How about automation side? What kind of changes is happening in automation when it comes to the?
Oh yeah, automation. That is well, really, when you look at automation, we've got to put that in the context of the other trends that are occurring. And there I see probably 5 things happening. First of all, non-pneumatic tires, they're going to continue to be a niche market. So I see the pneumatic tire, that's not going to change. That'll be around with us for another 10, 15, 20 years. So I don't see any change there. But the non-pneumatic, and again, this all ties back to automation. The non-pneumatic tire will only be in the niche markets like on off-road, skid steers, that type of application. The pneumatic tire will stay with us for one key reason, and that is to change will necessitate changing the vehicle cornering suspension system to compensate for the change in damping characteristics of the non-pneumatic tire. So the air is going to stay with us. How does that ties into manufacturing, automation? Certainly that will increase. The amount of level of automation will increase, and we'll see robotic building systems. The VMI Max system is part of the benchmark in that regard. The automated mixing systems and so on. So automation will increase. The issue with automation is going to be efficiency and agility. So on one hand, yes, it's more efficient if you have long runs of one specification, but with the changing of the diversity, I guess you could put it that way, and the number of tire sizes, designs, and so on, run lengths tend to be shorter, and the automated manufacturing systems don't really lend themselves to the shorter run cycles in the manufacturing plant. That shorter run cycles is going to be compounded more by, for example, tires for electric vehicles. That's going to create another set of challenges for the industry. So load carrying capacity of the tire will have to be improved. Tire reliability will have to be improved because of the removal of the spare tire, for example, to get the weight down on the vehicle. And then one challenge I see the industry is going to have to confront with is less emphasis on rolling resistance per se, because that is a one point in time test number, but more on in-service energy losses for the vehicle. So for example, for an internal combustion engine, ICG vehicle, around 7% of the energy consumption for a car is attributable to tire rolling resistance. When you go to an EV, like a Tesla or something like that, that 7% becomes up to 35%. So the energy losses due to the tire in an electric vehicle are a factor of 4, maybe 5 times greater than an internal combustion engine powered system. So that's going to be a challenge in meeting that. Modeling is certainly in the trend. That's one of the key trends. We see more and more emphasis on modeling. I tend to come from the school of you can never have enough data. So certainly modeling allows us to screen more options for before going into an experimental tire build, for example. But we still need to validate the model on the road with real-world testing. What modeling does allow, however, is an improvement in the quality of the decisions that are made in a new development program. And that is of paramount importance. Improving the quality of the decision making is critical, and modeling allows us to do that. In that broad area of automation, I see another opportunity going forward into the future. And that it really is, I guess, somewhat different, but in the sense of tire R&D management structures. I've seen some very efficient management structures, highly productive working environments, and I've also seen environments which lend themselves to improvement. I think this area needs a lot of work going forward, for it will have a big impact on the industry's ability to meet the challenges going forward, such as automation, developing tires for EV applications, the non-pneumatic tire, which is going into the more on-off-road applications. Again, reliability is going to be the big benefit there. And then, of course, like as we mentioned, automation. How do we bring in more automated plants and manage that in an efficient and productive manner? So it's a lot of challenges going forward into the future, and I certainly see automation is going to be a critical element in that. If we can also bring in systems which are sufficiently agile at the same time.
So how about the non-tire components, non-tire, whether it's OEM or automotive, and also the non-automotive products? What kind of changes you can expect in terms of the technology and material?
Yeah, good question. Certainly, when we look at the trends of what has happened previously, the under the hood operating temperatures have increased, and that's driven us away from use of polymers such as polychloroprene, the neoprenes, more to hoses being made from EPDM, so we have a better heat resistance and so on. That's all driven by the aerodynamics. Certainly, I would see that continuing. The big challenge confronting the hose manufacturers for automotive applications is going to be adhesion, EPDM, compound adhesion to the adjacent components and something like the hose, or the composite structure of transmission belts. The adhesion is a big challenge there, and that still remains an issue. Some of the adhesion technology, resin technology that has been used to improve component-to-component adhesion in belts and hoses has certainly contributed. The dicyclopentadiene resins have proved to be very effective at building good tack when the hoses are being built, and so on. In the larger products, like industrial products, conveyor belts, some of the same issues there. The durability is going to be the big one. I see the conveyor belt market potentially improving. We came across, worked in one project in Chile, for example, where moving product sometimes up to 40 kilometers is much more effective on a conveyor belt system rather than trucks. So trucks are more expensive. The tires extremely expensive on those 200, 300 ton trucks, big Rodgers Caterpillar trucks. Conveyor belt systems can be much more efficient at moving that product. So not only has it a lower environmental footprint, but the overall efficiency and cost of the installation, again, is much more effective. So yeah, with regard to the environmental impact, I probably see three things here. The number one would be, well, the three things are really going to be around pollution, climate change, and sustainability. I think pollution is going to be always an issue for every responsible tire manufacturer or industrial products manufacturer, in the sense that the processes and the manufacturing facilities must be designed to handle waste, both the post-industrial waste, that's scrap coming out of the plant, and then the post-consumer. You know, what do we do with all the waste rubber products once at the end of their service lives? And tire recycling is going to be probably the biggest challenge at the moment. But efforts to address the post-industrial and post-consumer waste, that has to continue, especially in the areas of recycling. And a lot more work needs to be done there. That will be an ongoing area. Climate change is always an issue. The United Nations has published another report which has raised this issue again, but at the macro level. But at the micro level, what can we do as scientists and engineers in the manufacturing of industrial rubber products and tires? I think that really brings us into the whole area of sustainability. And sustainability has had a lot of rhetoric and claims around it, but I think we need to convert sustainability into a hard science. It gives us an opportunity to put some hard engineering and technology into the debate, and that's going to be essential. It's going to be really important. I think the oil and gas industry has done a superb job at addressing this whole issue around sustainability. I did a study on this, and basically you can break this into 10 items. If I could just take some time to walk through that very quickly. Probably the most important is safety. And safety in tire manufacturing plants and industrial product plants is crucial. It's critical. A safe working environment is essential for all our workers in that environment, and the end users of our products as well. They have to be safe, reliable, and every effort taken to ensure that there's no risk of early product failure. Water conservation would be the second item in this one. Water is an issue all over the world, so water conservation, recycling. I've seen numbers in tire factories, some of the larger tire factories needing up to 7,000 to 12,000 liters of makeup water for every ton of product that's coming out of the plant. That's a lot of water. Power and energy efficiency, that's always an issue. Emissions, we want a zero emissions plant is the ideal. Materials conversion, the ideal is for every molecule of carbon coming in at one end of the plant goes out as the final product at the other end. It's the ideal. Equipment reliability, the preventative maintenance programs and overall efficiencies in the plant have a big impact on productivity. I think we'll see more effort in recycling, particularly within the manufacturing sector of our industry. That falls under that broad category of post-industrial scrap that we talked about, and that's the compounds, reinforcements, or the tires, for example, not passing the final inspection. How do we do that? How do we handle that scrap? Will always continue to be an issue. And then the secondary pollution controls. And pollution, again, is a sensitive issue. Secondary pollution controls, that's what do we do with pallets, wooden pallets, cardboard packaging disposal, excess chemical inventories, toxic materials, how do we handle those, particularly the volatile organic compounds, and then mold, flash, and trim that comes off the final inspection areas. So that's secondary pollution. Those issues need to be addressed. And then, of course, probably more important is the social awareness, the employee involvement, employee engagement, in the company, the community commitment, because companies can only exist with the consent of the community at the end of the day. And then what does the enterprise contribute to society? So, so when we step back and look at the the business environment we're operating in, pollution, climate change, sustainability, I'd say sustainability is of paramount importance, but we need to convert that into a hard engineering and technology science moving forward. So that is probably one of the bigger challenges to see this for the industry as a whole going forward.
How about what is your opinion about the recovered carbon black? We call RCB.
Oh, recovered carbon, yeah.
Yeah. So what is your opinion? I think many companies, many big tire companies talking about, okay, they use 70% sustainable material. Some are going forward 100% sustainable materials. Yeah. I think one product is a recovered carbon black. What is your impression or opinion on this?
Yeah, that is an area which you tend to see mixed signals in this one. Certainly the research and development work has to continue because we want to recycle. The ideal is recycle the products back into new products. And there's a lot of carbon in a tire, for example, that can be captured. The quality of the material is going to be of the utmost importance, because if we look at original carbon black, if, for example, we shift grade from an N121 to an N330 in a tread compound, that will have a big impact on tread wear, ballast to removal, enormous impact on a passenger tire or a truck tire. When we look at recycled carbon, that has to be produced to the same quality as we have with the original carbon blacks, and I don't think we're there yet. That's got a ways to go. Having said that, it can still be used, blended in at certain levels that will not have a detrimental impact on the end product performance. So there's more work to be done there. In terms of meeting the technical standards that are needed in order for it to be competitive with original black. And then part of the second area in that broad topic is the environmental impact on the manufacturing plant for the recycled. So the facility that is used to extract these materials from vulcanized products, there's a lot of pollution associated with those plants, and that would need to be addressed from that perspective. So it's the two areas: one, meeting the technical specs, and two is the environmental impact of the recycling plants.
What is your comment on this wearing out of tires, contaminating the earth and environment in large proportions, when you use for a long time these tires?
The fines
yeah,
from carbon black.
The wearing of when the tire gets wear, a lot of particles, tire particles.
Particulate matter, yes. Yeah. Okay, yes, I believe that is attracting a lot of attention in Europe at the moment, is the particulate matter coming from worn tires. That's another work, more work needs to be done there. I think when we look at treadwear, which is where the bulk of the material would come from, basically treadwear is essentially one of two processes. One is when you cut to the basics, a thermo-oxidative degradation. So I guess to be overly simplistic, the tread compound would be vaporized, or it can be a tensile tearing mechanism where we predominantly the particulate matter would emerge from. That tensile tearing mechanism, we'd have small particles which could be washed, end up in the water streams, which I think is what the primary concern is. I think that's going to be with us. The industry is working on it. We don't really have a clear solution to clear solution to the problem. We're still collecting data from the just last week. This came up, and very much we're in a data collection area. So I think we're still waiting to see what emerges.
That is one serious concern as well in an environmental perspective. Dr. Brendan, thank you very much, for joining and sharing us insights into what we can expect, challenges involved in the rubber technology. Before I let you go, you've been a consultant after retiring, and can you explain or give more information on what kind of consulting services you've been offering? So that the audience would be interested to take your assistance for their projects or the product development, please.
Oh yeah, thank you. Well, essentially, we've been working on one big project, which has been really exciting. It's been on graphene. That project is graphene goes back to around 2004 when it was first invented. It was expensive, but the new grades, the new technologies that have emerged over the last few years, the price has come down enormously, and now it's come to the point where it is feasible to consider it in, for example, high-performance products. It improves things like tear strength, abrasion resistance, the component-to-component adhesion, which is very important in a tire. It can improve hysteresis, better fuel economy, and all without any loss in other properties. For example, it can be a drop-in in many compounds, such as a truck tire tread compound. So that's been one very exciting project. I think it's got an enormous amount of potential, particularly in tires such as, for example, aircraft tires, where not only do we need good heat resistance, aircraft landings, for example, but also good abrasion resistance, and work very effectively in products like an aircraft tire tread. So that's one very exciting project. Also been doing other projects on butyl polymers to improve impermeability, adding additives to butyl to, again, give better air retention qualities, or reduce permeability in, for example, applications such as masks, face masks, and that sort of thing. Yeah. So some exciting projects there that are in place at the moment.
Yeah. Thank you, Dr. Brendan, for joining this session and giving all the insights into the program. I know rubber technology and its future. As I mentioned to all of you, Dr. Brendan is a consultant. If you're looking, some assistance, he's specialized with a huge experience on the compound development, both on the tire technology, and also the industrial rubber products. So you can reach out either to us or, to Dr. Brendan directly. Once again, Dr. Brendan, thank you very much.
Thank you.
See you in the next session. So thank you very much.